So the first node that we will set up inside the actor which is going to move is get all actors of a class with a given tag. This one. So it says that it will find all actors in the world of a specified class with the given tag. So we have this other event available to us, and this other event happens only once when we click on the play button. So we will have this node be executed after we click on play. So the class that we are looking for is a static mesh actor, as previously mentioned, and the tag that we are looking for is called path. This will result in a bunch of actors being stored in an array. We already know that there is just one element in this array, so I'll just do get the random array item, and this will give me the static mesh actor. Within this, I will get components, and I'll get the components by tag again. This time the type of component is the spline component, and the tag name is spline. Again, this will result in an array. So once again, I will retrieve a random array item. I already know that there is just one spline component. So now we have retrieved the spline component. So now what we will do is we need to get a location value from the spline, and we need to get that every tick. So one interesting note that we can use is the get location at time. And it says that the target is the spline component. There is a time input, there is a coordinate space, local or world. So this is just the reference point. If it's local, the reference point is not the world origin. It might be the actor's origin point. We will use the world point over here. And for this particular node's context, the spline has a time duration associated with it. Assuming that the position is changing based on the tangent, which is the slope, which is the rate of change, we can retrieve a position value given a time value. So the target over here will be the spline component that was retrieved over here. And for the time, we can set up a new time tracker variable, which is of the float type, the same type that we need to give over here. And we can name it as the time tracker. So all the attributes for this particular variable can be seen over here. For the default value, it says that please compile the blueprint. So I'll just compile it, and we can see the default value is 0. Now when we drag this variable into our editor, we have a get and set function. Get function retrieves the current value of the time tracker variable. Set value assigns a new value to the time tracker variable. So we'll get the time tracker value, and we'll increment it in some way per frame. So increment, we can just use the add operator, and over here we can add a really small value so that the time value is changing per frame, it is increasing per frame. And so this would be the new time tracker value. The new time tracker value will go in as the input. Okay, so here I will check constant velocity. What I need to do is assign the location of the current sphere that we want to move as this location value. So I'll just use the set world location, and the target is a scene component. So our blueprint also inherits from the scene component, but its parent component is the actual mesh. So I will assign the parent as the target. So I can use the get attach parent, which is under the transformation set of nodes, and this will get us the root scene component. And this should finally change the world location. So finally, what we will do is verify the execution order of the nodes. So every tick, we will set the new value of the time tracker, and after that we will set the new world location of the given root scene component, which has a static mesh associated with it. And then every time we click play, we will retrieve the actor called the path. We'll retrieve the component using the tag, and then provide this to the get location at time node, which will get us a location given a time value. So this should smoothly move the given sphere along the spline. So I'll compile this, and then I will click play or simulate. So here it says that there is a problem with the mobility, and so the reason it can't change its position is because it has a mobility that is set up, and which is this attribute, and it was set as static since that's the default for a static mesh actor. So we'll just set it as movable. So once again we'll click play or simulate. Oh, this is the path, sorry. We need to change the mobility attribute of the sphere, and the mobility is this attribute over here. We just make the sphere movable. So now we'll click on play or simulate. So we can see it smoothly moving along the spline. Another thing that we can do is we can draw a debug box in case we don't want to move the actor immediately. We can draw a debug box, and we can give the same location value for the center. The extent of the box, we can set it as a 2 by 2 by 2. The duration of the box will be how long the debug print has lasted in the scene, and thickness is just the lines. So we'll compile this, and we can click play. So it will draw a path as it is moving. So in addition to everything else over here, we can also set up some particle systems, and I have done that over here by adding a Niagara particle system component. Which is shown over here. We can also edit the asset to change the particle system settings. We can also add new spline points over here. We can edit the time input variable to change the speed of the sphere. So instead of 0.005, I can just say 0.010. Compile it, and it should go a little bit faster. And finally, I will leave you with a question. So at an abstract level, we can now move an actor given a path where else can we apply this? So thank you for watching.